Welcome back. Next up is Bogdans. He's a highly talented engineer, and he's going to tell you everything about the LoRaWAN network server, the Think Stack.
Hi, I'm Bogdan from the Things Industries. Today, I'll show how you can start using the Think Stack right now. To be more precise, today we will register a gateway. I'll be using Mqtt LR8. Set up and register an end device. I'll be using the Things Uno for that purpose, and with a small temperature sensor, so we actually have some real data to send over the network. Visit the concept of payload formatters. I'll be using JavaScript formatter to format uplink messages from raw bytes sent by an end device to human-readable JavaScript objects. And discover various integrations that the Think Stack offers that allow you to process data sent from or received by your end device. So first things first, in order to receive or send traffic, we need a LoRa-enabled gateway. Make sure to follow instructions provided by the manufacturer of your particular gateway. If you're having any troubles with that, you can visit our documentation page with guides on how to set up various gateways from different manufacturers. Once that's done, we need to register our gateway in the Think Stack. To do that, go to the Think Stack console and log in. I will log in via the Things ID as it allows me to use my account from the V2 console, also known as the Things Network console. So log in, go to Gateways, press Add Gateway, fill in your gateway details. For now, we need ID, EUI, and frequency plan. Gateway ID can be anything you want. Gateway EUI is provided by the gateway manufacturer, and frequency plan should match your region. Press Create Gateway and wait until it connects to the Think Stack. When your gateway is connected to the Think Stack, it's time to set up and register your end device, in our case, the Things Uno. But before we can actually register the end device in the Think Stack, we need some details. Namely, we need App UI and Dev UI. Open Arduino IDE, go to Sketch, Include Library, then Manage Libraries, search for the Things Network, and press on Install. Then go to File, Examples, the Things Network, and select Device Info. Replace frequency plan with one matching your region. I'll use the EU one. Before uploading the sketch, make sure that you selected target board to Arduino Leonardo and selected correct USB port. Then verify and upload the sketch. After a while, you'll be able to see the App UI and Dev UI. Now we can go to the console and register the end device. Go back to the Think Stack console, go to Applications, press Add Application, type the application ID, this can be anything you want, and press Create Application. Then press on Add End Device. Make sure that over-the-air activation is selected, then select Mac version 1.0.2 and leave the rest as default. Select your end device ID, again, this can be anything you want, then copy App UI and Dev UI from Arduino IDE and paste them here. Select frequency plan that matches your region, I'll select Europe, and select Phi version. Now generate the app key and press Add End Device. As you can see, the end device isn't available because we're actually not done. The device still has to join the network. So go back to Arduino IDE and select the Send OTAA example sketch. Replace App UI we got earlier, replace app key we generated in the Think Stack console, and replace the frequency plan. And that's it. But in my case, I'll use custom sketch that sends temperature values read from the sensor instead of the LED status. It is exactly the same sketch as the Send OTAA example, but with some sensor-specific code. Go to the live data view in the console and wait until your device successfully joins and starts sending the data. But there is still a problem. Instead of temperature value, we're getting this. That's because we have to tell the application server how to decode this value into something more descriptive, and that's where payload formatters come into play. Go to the payload formatter section of your device. You can find guides and examples for all formatters in the documentation, but now we will use JavaScript formatter. You can find more concrete examples of JavaScript formatters in device repository where manufacturers submit their formatters for their devices. Select uplink and define how to format bytes received as input. In my case, the logic is quite simple, as the end device sends only a single byte representing temperature value. Press Save Changes and we're done. Now, go back to the live data and observe the decoded payload. Okay, that's great, but what if we want to get that data and persist it in our system, be it a web application, mobile application, or anything else? We can do that via the ThinkStack integrations. Let's look into Mqtt integration. This integration allows receiving messages from the stack on their arrival. Go to Integrations, select Mqtt, and generate a new API key. To showcase Mqtt integration in action, I'll be using Eclipse Mosquito, but you can use any message broker of your choice. Set all required flags and wait for uplink messages to arrive. Here you can see temperature sent by the things Uno. But what if we don't want to maintain a persistent connection to the stack and query for messages when we actually need them? You can do that via storage integration. Go to Integrations, select Storage Integration, and activate it. From now on, the ThinkStack will persist messages for your application. You can query for saved messages via simple GET request. Please see our documentation for more details. For now, let's request the last 10 uplink messages. And here you are. Well, that's it. Obviously, the ThinkStack is much more powerful and has more features than I just showcased, so I really encourage you to try it on your own. Thank you for watching.